Okay, good morning. Good morning. So today we are still in Unit 3 because last week we just finished Unit 2, right? With the still remember what we have done last week. We do the comic books data set, right? Actually, in the first few weeks, we want everybody to get familiar with what is programming, right? But it's not that complicated, right? Programming is simply composing expression by data object, by operator, and also by function code, isn't it? It's all about. All about programming is that, right? So what make it complicated is that two things, right? One thing is like, first of all, you have the data object. It is not a single value, right? Right. It could be a data structure, right? And it can have many different types of data, right? Isn't it? Right. So this is the first factor that will make it complicated, right? The second factor that will make programming difficult is that there are a lot of function calls, right? So you, up to this point, you have not learned too many function code yet, right? Okay, and that function code actually, you don't really need to actually know every data structure. You don't really need to be familiar with all of the function code before you writing program. Okay, my philosophy is it's like you learning language, right? Your vocabulary, right? This function code, this data structures, were like you will have a larger and larger vocabulary, case by case, right? So today we will give you more cases, okay? In addition to the comic book case, right? Today we will give you more cases, and you will find that actually you don't really need to know too many function code. You don't really need to know too many data structure. Basically, it's just data frame and vectors, okay? Basically, it's just like very simple arithmetic and logical expression, right? As long as you can get familiar with some basic function code, then you can do like maybe 80 or 90% of the data analysis already, okay? So it's not that complicated, okay? Just make it simple. Programming is simply just composing expression by data object, operator, and function code, okay? And another complication is on the indexing, right? When you have a data structure, you sometimes want to like select, filter, or sort the data structures, isn't it? Right? So we learn the technique, and you don't really need to remember everything before you writing program. So I would like to give you case by case. You get familiar with this R language and the programming in the course. Okay. So today we'll give you 3 more cases. The first case is, I call it data detective. This is a data set about car stolen event. You know, there are vehicles, right? Car stolen events in Chicago, right? We have a data set about this car stolen events. Okay, so and the second case is the stock price. We will have 5 big company stock, for example, like IBM like P&G, like General Electronics, that type of big company, long-term data set. Okay, and the third case is the census data. You know that the United States Census data. Okay, so, again, you will find that with this data set and with the data structure, with the indexing, with the function that we have already learned, we can already do a lot of things. Okay. And actually, let's go to as I told you a lot of times, right? Every time you go to this class, you go to the class front page, right? And today we are in 4, right? Week 4, and data cases. You click here, you go to the unit page, okay? So today we have 3 classes. 3 notebook. I would say that 3 notebook. And then we will have something for you to download, okay? And you go here, and then basically you will see 2 things, right? The PowerPoint file. I told you that you want to download it to your home computer, and I suggest you download it to your C drive. And in your C drive, you have IB533. Okay, so you can download the PowerPoint. Okay, and also you want to download the zip file. If you already download it again, because yesterday I made some modification. So right, download it again. You put it into your code, right? IB533 code directory, okay? And 7. Now you go to the directory, IB533, and code. You see the zip file, right? So you want to unzip this file. Actually, sorry, maybe I should do this. In the zip file, there is a folder, right? You want to put this folder into your code directory. So after you do that, you have 03 cases, right? Isn't it? Okay. In your C drive, IB533 codes directory, after you unzip the file, you should have, you should have 1, 2, 3, right? So every unit we will have a folder. Okay, you should have something like this, and under this unit 3, these are the material that we want to use today. The source code and also the data. Everything is here. Okay. Now you want to go to the RStudio. Okay, and then you well, the easiest way is like you can click C, right? So you go to your C drive, and then you go to IB533 and press code, and then you have the 03 cases, isn't it? Right? And don't forget to like set here as your working directory. Okay? Go to your C drive, IB533 code 03 cases. Okay? And then click the gear and set here as your working directory. Okay? Everyone follow me? Okay, need more time? Okay, so let's get started with the first case. Okay? Now the first case is, I call it the data detective. Okay, so this is the code. As I told you, if you the first time when you want to set the code, you may see here that he will ask you to install the package, right? If that is the case, right? If here sometimes here you will see a yellow line telling you that you need to install some package, right? Just hit install, then you will start to install the package that you need. Okay. And then after you install the package, you want to execute the first code chunk, okay? And because I already installed all of the package, so the first code chunk is run out very quickly. And so far, some of you should still installing package, right? Okay, so meanwhile, when you install the package, let's take a look at the HTML file, okay? You press the HTML file, okay? Click the HTML file in here. Click the HTML file here, and let's click View in Web Browser, okay? Now, this is the notebook file, okay? All right. So the notebook file actually have some comments, has some explanation along with the code. You see that, right? So when you are installing the package, let's take a look at the basics of the basic data structure of the first case first. Okay, so the data is actually located in R in your working directory, and it's under data. It's called MV week 1 .csv. Okay, and we already done that. In order to read this file, before we can analysis a data, first of all we need to read the data into our working environment, right? Okay, so for this CSV file we use the .csv function, and after you execute this .csv function, we should have a data object created here, right? And here we name it as capital D. Okay, so this is the D is the data frame, and you can see here that it has about like 200,000 191641, right? About 200,000 car stolen events. Okay, and it has 11 variables. And the variable is actually explained. It is easier if you go to the HTML file. The first of all is the case ID. This is not it's just a unique ID. Do not have any meaning. The important variable here is the date. First of all, is the date, right, and time. If you take a look at the data, you will see that. Click here, and you will see here. It's actually the kind of like a timestamp, right? Okay. So every car stolen event is registered in the police station, right? So when you go to the police station, they'll give you a timestamp, right? So actually, it's and then the second thing is the location. Some car are stolen in the street, some car are stolen in the residential yard, right? And sometimes they are stolen in gas station, parking lot, that type of things. Okay? And then some case the thief are arrested, okay? And some are not. So this is the true false kind of logical, is the logical column, okay? And the fourth column is domestic. The domestic bit district community area is not that important in this case. Basically, we do not use this column, so it's not very important. But the year is important. Okay, this is the year that of the event. So the important variable or the important columns in this data set, first of all, is the date, and the second one is the location. The third thing is the arrested rate, right? And the first two, as you can see that so far they are written in as a character vector, okay? And the other important variable is year, okay, here, as you can see, okay? So in now, let's go to the, after we have some basic understanding about the data we are using. Actually, in this case, we are going to learn a few things. Okay. The first thing we want to learn is how to handle this date and daytime data structure. Okay, day and time is actually pretty troublesome. Okay, in the nature, day and time are continuous, right? Time is actually a continuous, something like a real time, right? Because every time spot, if you like, they are kind of like continuous things, right? But the human society actually the unit of time in the human civilization actually make it very complicated, right? We have year, but sometimes a year had 365 days, and sometimes it has 366 days, right? And we have months. Some months have only 28 days, 29 days, and some months have 30 days, 31 days. Okay, the unit is like very it's kind of messed up, right? It's not like the normal arithmetic, right? So day and time must be treated as a spatial data type in the computer, okay? So day and time must be treated as a spatial data type in the computer, so it can be complete. Before we compute them, we need to convert into a computer type of day and time data type. That is the first thing that we want to learn, okay? So and the second thing we want to learn is we want to do more practice in two functions, table and t-apply. Okay, this is what we are going to do today. The way we call it data detective is that now you are a police station, you are the law enforcement department, and you have a lot of car stolen events, right? What can you do with that, right? Maybe the first thing is you want to know is like kind of like when is the car stolen, right? The 7 time in 7 days and 24 hours. When is the car stolen, right? And the second thing you want to know is where the car is stolen, right? So you can allocate your law enforcement manpower, right? If you know that the car is stolen where, right? At what time, then you can deploy your police department to the place, right? So you have more probability to solve the case and retrieve the catch the thief and retrieve the stolen car, isn't it? Right? And before doing that, this kind of data, sometimes we call them temporal spatial data. We have space, we have time, right? An event occur in the space and time, and we want to know the distribution of event within the time space, kind of things, right? So that is the first. In Wilson's case, we also have a lot of this type of things, right? We have event occur in the time space, and then we want to know the distribution of the event, right, within the time and space. Okay. Now let's get started with some easy practice. Here we have a lot of question, right? After reading the data, the first question it asks you is how many rows of data, so how many observations are there in this data set, right? We have a command, right? We have a function called number of row, and we have another function called number of column, right? Okay. But actually, in order to answer this question, if you are in RStudio, you can see the number directly here, right? You don't really need to run this function to see the number of row, number of column, and also this. Actually, this is not very easy to see, right? And this is actually the data that you call str in RStudio is already displayed here, right? You can see that in this data frame we have so many columns. Sometimes we call it variable, right? We have so many variables. This is the variable name, and this is the type of data, right? So every column can be treated as a vector of, for example, ID is an integer, right? So this is the integer vector. The length of the integer vector is 191641, isn't it? Okay? And then day. So far, it's actually written as a character, right? Okay. Later on, we will have to convert it into a timestamp, right? As I told you that this character cannot be computed as time within computer, right? So before we want to do computation in time or date, we need to do a conversion. We'll learn it later, okay? And then location, arrest. Arrest is actually a logical variable, right? Because the case is either arrested or not arrested, so it's true and false. And the other important variable is year, right? The year that the case happened. Okay. Now let's. And actually, you can do a quick summary on the columns. As you can see that for this character variables, we do not see too many information of the summary. Okay, but actually, if it's the integer, you can see the minimum, the maximum, and actually the 1Q, 3Q, and the average and median, right? Okay, if it's numeric, right? If it was the logical, it will tell you how many of them are true, how many of them are false, right? Okay, and as you can see that this numeric things, you will give you the numeric minimum, maximum, average. Year is actually an integer, right? So it's numeric. Okay, and we also have a longitude and a latitude included in this case, but in for now we are not using the longitude and latitude yet, so don't worry about that. Okay. Okay. So far you should be able to execute this code chunks without problem, right? Okay. Now, use the max function. What is the maximum value of the variable ID, right? So this is actually your homework assignment, right? Okay. I'll let you as your homework assignment. It is very important, right? If you want to see the maximum of the variable ID, you can actually just look here, right? Okay. Or you can use the kind of like minimum. Sorry. There's a function called minimum, right? And we want to know the ID, right? The column name is ID, right? So this is the minimum ID, right? How many observations have the value of true in the arrest variable? Okay. I already told you that we can use this sum function, right? Okay. This is actually your homework today, but I will kind of like walk you through, so you can like. This week we will have a kind of like a team homework assignment, okay? So the TA, they were like in our TA will create a directory for each of the team, okay? So you can write the homework together and then upload the your homework, your group homework to the team directory, okay? So in this morning, I'll kind of like just walk you through the things important, and the average rate of arrested. This thing I will just leave it for you, okay? Okay. Here it asks about observation. How many observation has the location description value of alley? Okay, a very easy way to do that is that you can do it this way, right? You can sum the location equal to you can do this, right? This is a way to, actually you don't need to like type location description all the way, okay? As long as you can like, here I do not type in the entire column name, right? Okay? In R, it's actually, it gives you a lot of convenience as long as you can recognize You cannot type LO because they are LOC and also LON, right? But if you type LOC, you can recognize you are talking about the location description, right? Okay, so this is one way to do that, right? The other way to do that is to do a kind of like table, right? And then you do a table on LLocate. See what will happen. I would suggest you also do a sort. So say also I have a typo here. Now you can see there are a lot of different locations, right? And some location already only have one occurrence, so you may want to like do a tail, like okay. So this is the 10 location that has the most car stolen events, isn't it? Right? So table is actually a very, very, very good, and you can see that they are 2308 car stolen event occur in this alley location, isn't it? Okay. See that? Okay. So table is kind of like very handy. Okay. So in order to solve a problem, you actually have many, many different ways to do that, isn't it? Okay. Now it comes the most important thing that we want to learn in this notebook is the day and time conversion. Okay, as you can see that when we read in the data, this column is actually read in as a character vector, right? Okay, as a character vector. So if we can take a look at the first few head, it's actually you would by default, you would pick 6 value out of the first 6 value in this vector, right? So you can see that they are double coded, so they are actually string, right? The problem is when you see this, you really it's really hard to imagine. This should be the day, month, day, and year, right? And it could be year. So it, in this format, in the character format, in human society, we actually in different place we people kind of like write time in different format, right? Sometimes you write a year in the front, and then put a dash, and then months, and then dash day, right? Okay. And sometimes they use sometimes they will call the month like 2025 and October the 1st, kind of like that. Okay. So different people tend to write the time character in different format, right? So the computer cannot recognize the this character string as day, right? So if you want the computer to kind of like recognize the day and time, you need to use this function code. It's called the POSIX. POSIXT. This is international standard timestamp. Okay, a computer time. Okay, and you need to give this when you call this function call. You give it 2 things. The first thing is the character string. Okay, and the second thing is you need to tell this function what is the format that the datetime is recorded in the character string. In this example, we have month. Okay, let me do this. I think it would be easier. In this case, we have month as 2 character, right? And then followed by a slash, and then followed by a 2 character date, right? And then followed by a 2 character year, okay? So you can actually check here, year 2 character, then it should be, it's the code for year, right?
Or if you want to make it 4 characters.
If you want to make it 4 character, there's a percent capital Y. You see that? This is kind of like a converting code, right? See that? If I write it as 12, 31, and 2012, and then here I should use a percentage capital Y. You get the point, right? And then this is hour and minute, right? Very obviously, okay. So you can actually check this table. Sometimes you using year like this, and then you need to use percentage capital Y, and sometimes you separate the year and day by dash, right? Okay, and in that time you need to put dash here. So you need to tell the as posted. You need to tell this function code what is the format that you return your data, okay? And the converting table is here, okay? Some people like they will write day a month like this, right? And sometimes they will write weekday in this format, and sometimes they will use like abbreviated time. Okay, so it's kind of you need to tell computer what the format is before it know how to convert the character vector into a computational into a computer time. Okay, so this function actually can convert character string of datetime, okay, in a specific format into a computational computer timestamp. Okay, you actually can call it timestamp, the full name, but usually I will use a shorter name. I just call it TS, right? So after we do this conversion, you will see that after we do the here we have a character vector of 191641, right? So after I do this conversion, I told you this POS IXCT is kind of like international timestamp standard, okay? So don't worry about the time. It will convert as a vector. It will take some time, okay? And after it convert, you can see TS is actually a POSIT vector. This is the computer time, okay? Of 191641. So it's actually, the length is exactly the same as this vector, right? Okay? So this TS is computer day and time. So when we want to do computation, we want to see the distribution, we need to use this TS vector instead of the date column. Okay, see that? Now, if I want to do a histogram, okay, see here I have this TS, right? Now TS is now the computable time and date, right? So I can use this histogram to see the distribution, right, of the car stolen event. Okay, and you actually TS you can specify year, then every column will be a year. Okay, see that? Okay, and then you can see that the last two is actually to rotate the. Otherwise, if you write this x-axis label as in horizontal way, then they will overlay with each other, right? So this last two is just rotate the labels in this way, okay? And here I specify frequency, and it means that here is the number of time the event occurred, right? And then the man is actually just to specify the title of the plot, okay? And from time to time you will see this like when I do the plotting, I put the par here, right? So don't worry about that. It's just to set the format of the font size, that type of things, right? So you can basically just ignore this part things, okay? It's just to make the plot looks better, okay? So now you see that when we read in the time and the day data, it will be read in as character, but in order to do something about the day and time, we need to convert it into a computer daytime, right? Okay, so the computer timestamp, if you have time and date, you need to use this function called SPOSIT. This is the international standardized computer daytime, computer timestamp, okay? And after do that, you can do the kind of like histogram, that type of things, okay? See, so this is the first thing that we can do. And the second thing that we want to do is that now we have the time stamp vector, right? And there's another function called, it's called format, right? You can actually extract the weekday out of the TS by the format function code, okay? Let's take a look at. Actually, it's already 10 o'clock. Let's take a 10 minutes break, and we'll be back at 10 after 10, okay?